Hi everyone, once again welcome back to the channel. In this video we are going to learn how HPA and VPA going to handle in the Kubernetes. In the right side we have the Hanuman character is going to tell the story about the VPA. On the left side we have the Ravana character is going to tell about the how the pod replica is going to create or decreasing or increasing the pods based on your traffic. So these two characters I basically you guys know about from the Ramayana. So let's get started in this video to start the VPA and HPA to understand how they hacked in the Kubernetes. Okay, first before we are doing this project we have to install the EKS cluster in the Amazon. Okay, I'm going to show some required packages required to perform this project. So we required one thing, AWS CLI and the kubectl, EKSCTL. These three packages we require to install in your Ubuntu machine or Linux, what you like you are using, CentOS or like that. And one more, Git also we have to install it. Okay, I'm not going to explain this all those packages installation in this video because it takes some time to installation and it consumes explanation also. And here straight away I'm going to create first thing I'm going to explain of this command. Here I have already configured the AWS config. If you don't have, you just go with the AWS user account and create the access key over there. The first thing I'm going to create here, yeah, now the cluster is creating. Now in this project I'm using this C68 and X large. Why means this instance types have the 4 core CPU and the 8 GB RAM. I'm going to show here. Click on the instance type on the left side and here I'm going to just copy paste this instance type. Is going to filter it out. Here you can see the CPU is 4 core and the memory is 8 GB. For this project is enough to do this instance type with this instance. And if you don't have much you don't like to spend much amount, means you can go with the T3 medium. This is enough to do the project because it's going to give only 2 cores and 4 MB memory. That is difference. And here also I just calculated it how much they going to cost by using this type of the instance C6 is going to cost. If you doing this project within an hour, you have to spend at least 15 rupees in the Indian currency. Approximately 20 rupees you have to spend because we are using the control plane, right? That's why we have to spend at least 20 rupees. Okay, and you can also use the T3 medium if you don't have any like to spend much amount, means. And one more thing you have to observe in this, we are using the EKS cluster version 1.33. okay, go to the Google. One more thing I will show. Go to the Google, type Kubernetes current version or release, you type it and the first option go here. Now the recent current market in the Kubernetes have the 1.34, okay, release version 1.34. We are using the 1.33. In the future the version going up to 1.35, 36 like that. You have to change that version in the command line. Okay, and we are using the 2 nodes. Minimum you should handle the 2 nodes, and the each node I given the 20 GB of memory, because if I did not given this volume size 20 GB, it going to take up to 80 GB to the per node. Okay, it going to cost more. That's why I'm given the 20 GB. Okay, and let's check it is whether is yeah, still is going on. Yeah, for this project this is the main thing we have to check. if you are doing the manual EKS cluster configuration, you have to enable this add-on metric server. So keep in mind, and let's go to the topic now. I'm going to clone my repo first thing. This is my repo. I given this link in the description box below. You can check it out. Where it is, yeah, go to the Visual Studio Code, close all. Okay, git clone and paste it. Just clone the repo here. Fork my repo if you like to do the project in your system. Okay, I move to the Kubernetes here. Basically, I just created one of the Docker image. You can also, if you don't like to use my Docker image, means you can create your own style of the Docker image. And we are going to exploring the first thing in the VPA. In the deployment section, first thing we are going to deploy about the VPA. Okay, and here we are using the 2 replica sets in the VPA deployments, and we are using the this is the my Docker image is going to pull from my Docker profile ID. Okay, and the container port is 80 because I am using the Nginx. That's why. And here I am setting the resource and limits to the 100 millicores, and requesting first is going to request the 50 millicore. If gets any some extra load on the pods, means is going to up to 100 millicores. Okay, now I set the 64 megabytes of the memory, and the limits also I am just set the 128 memory. Everything is same. I am using the liveness prop. This is don't worry about these things, just leave it. And the service I am just exposed to access this service post via the cluster IP. For the testing purpose, this is enough to do it. Okay, and this is enough. Don't later we are going to explore this VPA section. Just observe this first thing. Okay, and let's move on to the still is going to creating it. Okay, now I'm going to show. Now we have the one of the pod, right? Here we have the Hanuman character here. This person, the Hanuman, is going to reach the Lanka from Bharatkhanda to Lanka, right? So you don't have a power to jump from the India to Sri Lanka. So what we have to do, they have to increase their size from like this same person. The same pod going to increasing it. Can you see? Earlier you have the power only 100 millicore and the 512 MB of the memory. Just assume like that. And now you have the power to jump from the one place to another to give some extra mile to serve the data to the user like that. Okay, now they have the power 2 GB of memory and 1 millicore. So to understand the millicore, I just given the prompt in the ChatGPT. You can see it in here. In Kubernetes value 1 millicore and 50 M 500 M are CPU resource limits. The M stands is millicores. Okay, millicores. One CPU is 100,000 M millicores, 1000 millicores. Out of one CPU, we given the 100 millicores means is going to consume 10% of the CPU core. Okay, if you give on the 500 millicore means is going to consume 50% of the CPU shared CPU cores. Okay, like that we have to check it, and we are just blindly we are just deploying the pods. We are not implementing any here. We have vertical auto scaling like that. Okay, once the cluster is getting up, we are going to applying it. It takes approximately 50 minutes. Right now I'm going to pause the recording. I will come back once the cluster is up. Okay. Yeah, now the cluster is installed and we got the 2 nodes here, and let's check the CPUs. We have the 4 CPUs in one of the node, and the second node also we have the 4 CPUs, and the storage is 20 GB. Okay, let's cross check the Kubernetes. Okay, the cluster is just now created with the version of 1.34. If you like to do the latest version, means you just change the version 1.34 like that, and the add on the main thing here, the metric server going to capture the CPU and memory utilization matrix. So make sure if you're doing the manual cluster creation, means we have to add this metric server, and one more deployments we have to install in the EKS cluster, because for the VPA the matrix server not going to help. That's why we have to install the VPA. So for the VPA, here there is a code cloud website I given here. This is the one of the documentation VPA I got it from the online. Here they just explained how to VPA pods we need to create, and what are the required deployments we have to install it. And the main thing is for the VPA, this is the GitHub repo of the Kubernetes. I will show here. This is the official GitHub repo of the Kubernetes. Here you can see the one of the path, Vertical Pod Autoscaler. Here what will happen, Autoscaler hack, this is the path hack, and yeah, here it is, VPA up. Yeah, this is the script is going to help to install the VPA deployments. Okay, so make sure you installing this Autoscaler. That's why I'm saying in the manual work. So if I just installed this deployment of the VPA, is not, you are not going to understand. That's why strictly I'm saying first let's monitor the first update the cluster in your machine. This command is going to help to update your cluster in your command line. So it helpful for to check the things. kubectl get nodes. Okay, we have the 2 nodes, we got the access, and okay, let's this one also let's run it. Yeah, and what we have to do, let's clone the repo first thing. I given the link here in the GitHub. First thing, let's clone it. Come back here, git clone. Approximately it have some 250 MB, maybe it's have. You can observe in the below. Yeah, see the 250 MB repo is just cloned my local machine. And let's move on to the path autoscaler virtual hack. Enough. Okay, now we are entered the part to the hack. Now let's start this VPA up. You're not getting right. VPA up, and just observe here the command I will paste it to monitor the things. Currently watch. Yeah, Let's apply this one. The top one is nodes, so don't get confused, and the bottom is just we are installing the VPA deployments. Yeah. See, the VPA is up and running. These are the required deployments we needed to make that changes in the VPA section. Okay. Now we have installed the VPA, right? Let's move back to your project, AS project. Cross check it, kubectl get pods. Right now there is no pods in my default namespace. Okay. Now what I am going to do, kubectl apply deployment. So I am not entered in the HP VPA apply deployment. Just I am applying the deployment. Okay. Watch. See, the container of 2 deployments is running and just creating and running. Okay. Now what we have to do, now let's cross check the pod description. I'm going to split it. This one is not necessary. I'm going to close it. Okay. Horizontally. Okay. kubectl describe pod VPA deployment and take one of the pod name. Okay. Here in the description pod, you just cross check it here. The request is 50 millicore and the 64 MB megabytes memory, and the limit it going up to 100 MB is going up to 100 MB, 100 millicores and 128 MB memory. Okay. Now what we have to do now, and one more I'm going to show how. Okay. So I will make the terminal ready in the easiest way to understand. Okay. Yeah, I just set the terminal correctly to understand, and here just take this commands to check in your machine, and this one is for VPA to check the things is applied or not, and is going to describe the pods whether is pods is updated the CPU and the memory like that. So we have the pods, right? We have the 2 pods, BH and HZ. Okay, just observe in the left side section what I am going to do in here in the down below right side section. I am just going to describing that pod details VPA. I am going to check the BH. The current, as you seen, this is the current deployment changes. Okay, and just observe whether the BH or HZ is the same or is going to change the new pods by after applying the VPA. Okay, kubectl apply of VPA. Okay, now I am going to applying it. Let's monitor the VPA now. The VPA demo is just created, and just observe in this block in the right left side top above, this 2 is going to change after some time. Okay, now is 2 minutes 40 seconds they just applied it. Let's check it. It takes some time to upgrade the things. See, the VPA is now 200 millicore and 250 memory given in the virtual autoscaling group. So it takes some time to affect on the pods. Just observe what is happening. See, after 1 minute is going to destroy one of the pod. See, earlier it was HZ, now it was HC. Okay, now let's cross check it. VPA deployment HC. See, now what I requested in the VPA deployment section, I will show in the moment the script, and it's going to giving the limit there. Only dynamically they setting the limit. I given the 200 millicore, they set in the limit up to you can use the 400 millicore. I given the 256 megabytes of the MB per pod. You can utilize up to 500 MB. Okay, let's dive into the script section here. VPA. Here what I am doing, you just monitor the pods by help of the vertical pod autoscaler, and the target. What is the target? This is the target. App version 1 deployment is my pod is the pod or deployment like that, and the name VPA deployment. See, VPA deployment, kind is deployment, app version A1. The same, the target group I given here. In the update policy, we have the 3 options: off, auto, and the recreate we have, and the container name. What container deployment you have to affect it? VPA container. See, I given the container name as a VPA container is going to affecting this deployment VPA container. Okay, the minimum amount I given here, you can cross check it. Minimum allowed 200 millicores and 256. You can ask me why you are given the maximum allowed. So now what I am going to do, I am going to change this to the 400, and this one I am going to give 512 MB. Okay, now observe here in the left side. Now the memory and the CPU is just I given the 200 milli and 256 MB, right? Now the 2 pods are just recreated and resized their power. Okay, now the pod is 9 and the HC. Let's observe once again. I am going to applying it. Just save it once you change it. Just save it. Just updated this 2 minimum allowed. Okay, let's apply once again. Configured. Okay, now just configured, and it takes up to 1 minute to update your pods. And you just observe the left side section, don't check out the right side section. Okay, now one of the container is just destroyed and created it. See, earlier it was a 9, now is the FC. Once again cross check it in the down. kubectl describe pods FC. See, when I increase the CPU or memory power, it automatically creating one of the new pod. Thus the person is same, the memory of the person is same, but they increase the power. Earlier we set on the 200 millicore, right? Now I set on the 400 millicore and the 512 MB memory. Now they're duplicating and giving the upper limit to the 800 millicore. You can utilize up to 800 millicore and giving the 1 GB of memory. Yeah, we just learned about the VPA. Here one thing we have to keep in mind. the number of replicas is not going to increase in the VPA. Only in the HPA, when you apply the horizontal, is going to replicating your deployments. In the VPA, the no replication is happening. Okay, now let's move on to the HPA. Now delete the things, the whole. Also, I'm not explained here, right? Maybe I explained it. Okay, let's delete the everything. This is the command to delete all the deployments and everything. Okay, now the deployment of the VPA is just destroyed. Okay, now let's move on to the HPA section. Here we have to check in another way, like that. Move on to the HPA section, cd HPA, delete this one. Okay, let's check it. The same as it is in the HPA VPA what we did in the deployment, the same thing, memory power and limitation resource request, everything is same. The service also same, but the service name is just given the HPA service. Okay, in the HPA sections I am going to say show afterwards. Okay, first let's apply the deployment, kubectl apply deployment. Check out here, 2 deployment pods is just created in the HPA. Okay, this is a HPA pod currently running the 2 replicas deployment. Okay, now let's watch the kubectl get HPA. Can you see there is no HPA is in the namespace, default namespace is running, not running anything. Okay, for this HPA, this metric server, what I say in the kubectl, this is the most important. Okay, and let's apply the thing, kubectl, where it is, yeah, we have it. And let's generate some load. This is the command to generate the load in the HPA. In the downside, I'm going to generate the loads. Okay, now you can see one of the pod, this is load generator pod, not the HPA pods. In the right side, kubectl get top pods. Sorry, my bad. Yeah, this is correct. See, there are 2 pods of the HPA and one of the pod is load generator. Right now below you are generating the request to these 2 pods. Now I am going to applying the HPA right now. The kind is horizontal pod autoscaler. In the VPA is vertical pod autoscaler. Okay, everything is same. The scale target reference is I am just referring that HPA deployment, same as here HPA deployment. Okay, referring it, just referring it. Minimum you have to maintain the 2 replicas, maximum you can perform the 10 replicas you can create it. The resource utilization just given the 20. If the 20% is cross the CPU utilization is going to take up to 10 replica set. Okay, now let's apply it, kubectl apply HPA. Okay, sorry, yeah, HPA is now created. Cross check it. Here you can see in the left side this block, just observe this block. Okay, this one is not getting properly. I will going to close this one. I will close this one. I will start it in the new tab, new window. I will generate it here. This one you are not going to see properly, that's why. Okay, this is much better. Done. And let's generate some load. Where it is here. Don't worry about this load generator command. Okay, is generate only load. Now the two horizontal deployments have the only 2% of the load, right? So for the to understanding purpose, what I am going to do, I am just decreasing the utilization to the 1%. Okay, just 1% I am going to giving it and applying the HPA manifest file. Now see what will happen. The target earlier is the 20%. Now I given the 1%. Okay. Now the CPU utilization per pod is 12% is going to increase, 16% like that. And let's observe. You can see in the left side, immediately the pods are creating. Okay. Immediately, and you can see the replicas. You will going to update in the few minutes. You see the 4 is just updated, and eventually when the CPU get more workload, means is going to create more and more deployments like that. Okay, the current utilization of CPU is 16% across all the pods. The 10% is going to decreasing it. See, and the replica right now is 8. Replica is currently is working. The utilization of CPU is just distributed across all the deployments, and you can see now the 5% is workload is distributed all the deployments. Almost the 10 replicas is just created. This is the pod details, top pod details. All the 10 replicas just created, and they share the memories, CPU millicores, okay, resources. You can see the age is 57, 42 seconds like that. Okay, now we have to observe one more thing here. I am going to deleting this HPA pods right now. Let's cross check it. I am going to set one of the timer online stopwatch. Yeah, what I am going to do, I am going to deleting the HPA pod. Okay, not deleting HPA, just HPA manifest file. I am going to deleting it and start. See, I just deleted the HPA deployment manifest file. Yeah, I monitored the 5 minutes. Right now still is the HPA is deleted, but the pods is just taking the replica set to the 10. So what is happening here? We deleted the HPA, right? But they applied the override the manifest file of the deployment. Okay, what we have to do now? Apply again the deployment of your HPA pod deployments. Okay. Now see, I am not changed any deployment, but it is configured because the overwrite happened in the manifest file of the deployment. See, eventually is going to destroy the remaining pods, but now the CPU utilization is getting high. It's not showing the HPA right now. Okay. Now I am going to still is the traffic is high only. I'm going to stop it, the traffic. Okay. Now we have to observe one more thing. We seen the deletion of the HPA and apply of the HPA, right? We did not monitor the live of the increasing or decreasing of the pods. So for that case, what I am going to do, again I am going to applying the HPA with one of the CPU utilization matrix. Again I am going to apply kubectl apply HPA. Okay. Yeah, is HPA is configured to the 1%, but the load is not here right now. Okay, there is no load. Right now I am not going to deleting any HPA these things. There is no load, but they created one more pod here. So what I am going to do, I am going to generate one of the load again. This is a different case of the to understand HPA. Okay, I am going to start the load and see the timing, how much is going to take after the load gets low. Okay, replica is 4. Now the load is generating, the pods also is getting increasing. So we have the 10 out of 10 replicas, right? Now what I am going to do, I am going to stopping the request traffic. Okay, I am going to stopping the traffic. Now let's observe how much is going to take to downscale the pods. Where it is, yeah. How much time is going to take to downscale these pods? Now the pods is get increased, right? The time is ticking up, but my deployment pods are still in the high only, serving the high deployments web servers data. Let's monitor how much time is going to scale down the pods. I'm going to pause the recording. See, to scale down the pods, it takes approximately 5 minutes, 300 seconds. So I recommend to change from here 1% CPU utilization to 10, because if you given the 1 means is not going to scale down your pods. I recommend for the testing purpose give the 10, and in the production they use the 60 to 70% of the threshold they giving in the production. So for the testing purpose give the 10 is enough, otherwise your deployment not going to scale down. Okay, for checking purpose I am just ChatGPT asked here to scale down stabilization window is 300 seconds, 5 minutes is default. Okay, now we understood the HPA and the VPA in the both the ways. I hope you enjoyed this video, and the same way how the Ravana heads increasing when they are attacking from the opposite side, they increasing their power. The person is same, memory is same, but they increasing their head count. Like that's the same way we understand the VPA and HPA. So if you like to do more projects like related to this DevSecOps, Kubernetes or DevOps, AWS projects, this is my website arishanshetty.github.io. Go here in the left side projects, you can, if you select that projects card, you will get the number of projects available already here, and you can also filter it out what project you like to do. Okay, and I hope you enjoy this video. If you like this video, like and subscribe, and share in across your friends circle. And once again, happy Dasara to all. Once again, thanks for watching the video.